Hello everyone, this is the challenge question walkthrough for Edexcel's Applied Year 1 textbook, and this is the second part for mechanics, and in this video we'll be going through all of the challenge questions in chapter 10. Okay, our first question is from exercise 10b. An object is acted upon by a horizontal force of 10 I newtons and a vertical force AJ newtons, as shown in the diagram. The resultant of the two forces acts in the direction 60 degrees to the horizontal. Work out the value of A and the magnitude of the resultant force. So if we redraw these forces in a triangle, we have 10 acting along the bottom and A going up. So if this here is 10, this is A, then this is the resultant force. And this resultant force will have magnitude the square root of A squared plus 10 squared. And we're told that it acts in the direction 60 degrees to the horizontal. So this angle here is 60 degrees. And using right angle trig, we can find the value of A. So we have that tan of 60 degrees is equal to opposite over adjacent, so that's A over 10. And so we have that A is equal to 10 tan 60, which is just 10 root 3. And now finding the magnitude, A squared is 10 root 3 squared, so that's going to be 300, plus 10 squared, which is 100, so we get 20. And so we found the magnitude and the value of A as required. Okay, our next question is from exercise 10c. A small stone of mass 400 grams is projected vertically upwards from the bottom of a pond full of water with speed 10 meters per second. As the stone moves through the water, it experiences a constant resistance of magnitude 3 newtons. Assuming that the stone does not reach the surface of the pond, find for part A the greatest height above the bottom of the pond that the stone reaches. So if we draw a diagram of what's going on, we have our stone here, and it's being projected upwards with speed 10 meters per second from the bottom of the pond. And we know that there'll be water, and the resistance that the stone experiences as it is projected upwards has a magnitude 3 newtons, so that will look something like this. And obviously we have the weight of the stone acting downwards, so that is 0.4 g. Remembering that we have to find the mass of the stone in kilograms. Okay, so we can use Suvat to find the greatest height above the bottom of the pond. So we know that the initial velocity is 10, and as the stone is projected upwards, at its greatest height, its velocity will be 0. And we know that the final velocity will be 0, as when the stone is at its greatest height, it will be stationary as it prepares to fall back downwards. And we can find the acceleration from this diagram here using the forces and F equals ma. And we're trying to find S, the greatest height. So first we can find A. So resolving upwards here using F equals ma, we get minus 0.4 g minus 3 is equal to the mass of the stone, 0.4 times acceleration. And so we get the acceleration is equal to minus 0.4 times 9.8 minus 3 over 0.4. And putting that into your calculator, you should get minus 17.3. So now we have enough information to work out S using the equation without t. So that will be v squared equals u squared plus 2as. So we have 0 is equal to 100 plus 2as. 2a is minus 34.6, and then we have the s. And so s equals 100 over 34.6. And putting that into your calculator, you should get 2.9 meters to two significant figures. Okay, for part B, find the speed of the stone as it hits the bottom of the pond on its return. So we'll have the stone is now at its greatest height, So if we redraw the stone, let's say the greatest height is here, where this is 2.9 meters. We still have the weight acting downwards with magnitude 0.4 g, but this time the resistance due to water will be acting upwards as the stone begins to fall back down with magnitude 3 newtons. So again, we can use F equals ma, but this time we will resolve downwards because the stone is moving downwards. So resolving downwards using F equals ma, we have that 0.4 g minus 3 is equal to the mass of the stone, 0.4, times the acceleration. So this time we have that the acceleration is equal to 0.4 times 9.8 minus 3 over 0.4, which is equal to 2.3. So doing Suvat again here, we know that the distance it has to fall is the same 2.9 that we have here, so we can use 100 over 34.6 for this. We know that the initial velocity will be 0 as it's at rest before it falls back down again, and we're trying to find the speed as it hits the bottom of the pond on its return, and we know that the acceleration downwards is 2.3. So again, using v squared equals u squared plus 2as, the equation without t, we get that v is equal to the square root of 0 squared plus 2 times a times s, 100 over 34.6. And putting this into your calculator, you should get 3.6 meters per second to two significant figures. And finally, for part C, find the total time taken for the stone to return to its initial position on the bottom of the pond. So the total time will be equal to this time here and this time here summed, as the stone will be on its way up to its maximum height and then it will travel back downwards. And so we need to sum these two times here. So for our first value of t from the journey going up, we can use the equation v equals u plus at. And so we have that 0 is equal to 10 minus 17.3t. So we have that t is equal to 10 over 17.3. And doing the same for the value of t going back down, we can use the equation s equals ut plus a half at squared. Therefore, we have that 100 over 34.6 is equal to 0t plus a half at squared, so that's 1.15 t squared. So we have that t is equal to the square root of 100 over 34.6 over 1.15. Okay, and to find the total time taken, we need to add these two values of t together. So putting this into your calculator, 10 over 17.3 plus the square root of 100 over 34.6 over 1.15, we get 2.2 seconds to two significant figures. That's our final answer. Our next question is from exercise 10D. A particle of mass 0.5 kilograms is acted on by two forces. F1 equals minus 4i newtons and F2 equals ki newtons plus 2kj newtons, where k is a positive constant. Given that the particle is accelerating at a rate of 8 root 17 meters per second, find the value of k. So if we draw this particle out, we have one force, F1, acting in this direction, that's minus 4i. And the second force we can split up into two separate forces. So we have ki going in this direction and 2kj going in this direction. Finding the resultant force, we call that R. This is equal to the first force plus the second force. and that is equal to k minus 4i plus 2kj. And we know that the particle is accelerating at a rate of 8 and the square root of 17. And now we can use F equals ma, where F is the resultant force. And we're given that the magnitude of the acceleration is 8 times the square root of 17. So here we have k minus 4i plus 2kj is equal to 0.5 times the acceleration. So we have that the acceleration is equal to 2k minus 4i plus 4kj. So we have that the magnitude of the acceleration squared is equal to the I component squared, so 4k minus 4 squared, plus the j component squared, so that's 16k squared. And expanding out the brackets here, we have 4 times k squared, then we have minus 8k, so that's minus 32k. Then we'll have plus 16, so multiply that by 4, we get plus 64, plus 16k squared, so that is equal to 20k squared minus 32k plus 64. And we know that this is equal to the magnitude of the acceleration given here squared. So 8 root 17 squared is 64 times 17, so that's 1088. So rearranging, we have 20k squared minus 32k, bringing the 1088 to the other side. So that's 64 minus 1088. That gives us minus 1024. That is equal to 0. I'm putting this straight into your calculator. And using the quadratic solver on your calculator with coefficients 20, minus 32, and minus 1024, we get that k is equal to 8 or minus 32 over 5. And in the question we're told that k is a positive constant, so we reject the negative value and we get k is equal to 8. And that is our final answer. Okay, and our final question for mixed exercise 10. In this question, I and j are the unit vectors east and north respectively. Two boats start from rest at different points on the south bank of a river. The current in the river provides a constant force of magnitude 3i newtons on both boats. The motor on boat A provides a thrust of minus 7i plus 2j newtons, and the motor on boat B provides a thrust of ki plus j newtons. Given that the boats are accelerating in perpendicular directions, find the value of k. So we can start by finding the resultant forces for boat A and boat B. So for boat A, let's call the resultant force RA. That is equal to the current in the river, so that's 3i, plus the thrust from the motor, that's minus 7i plus 2j. And so we get 3 minus 7, so that's minus 4i plus 2j. And for boat B, let's call the resultant force RB. That will be 3i again, plus the motor from B, and that is ki plus j. And that gives us 3 plus ki and just j. So the question tells us that the boats are accelerating in perpendicular directions. So we need to look at the acceleration of these two boats. So we can do that using the equation F equals ma. But what we can do is we can spot that the acceleration will be parallel to the resultant force, because the value m is just a scalar quantity or a constant. So if the boats are accelerating in perpendicular directions, that means that their resultant forces must also be perpendicular to each other. So if we think about what these forces will look like on a graph, if I do boat A in red, so we have minus 4i plus 2j, so that will look something like this. So we've got this length here is 2, this length here is 4. And now if we look at boat B, it will be perpendicular to the red vector, and it will have height 1 and length here 3 plus k. Okay, we know that these two vectors are perpendicular, so we can draw in a right angle sign here. And we know we can find the angles here and here using tan. So if we call this angle here theta, this one phi, we know that the tan of theta will be opposite over adjacent, and the tan of phi will be the opposite over the adjacent of the blue triangle. So here we can find theta as the inverse tan of 2 over 4. Put this into your calculator, you should get 26.565 degrees. And from the diagram we can see that phi is equal to 180 minus 90 minus theta. So using the answer button on your calculator, 180 minus 90 minus answer gives us 63.434 degrees. And so we have that 1 over 3 plus k is equal to tan of 63.434. So using the answer button on your calculator again, tan of answer is equal to 2. So therefore we have 1 is equal to 6 plus 2k, so k is equal to minus 5 over 2. And that is our final answer. And that is the end of Edexcel's Applied Year 1 Mechanics Part 2. I hope you enjoyed, and I'll see you for Part 3.